All right, we're going to continue solving inequalities. We're going to look at nonlinear equalities today and see how we can write those in that same interval notation. Guidelines for doing this: we want to move all the terms to one side to make it comparable to 0. There's going to be some factoring involved most likely. We want to determine the values for which each factor is 0 and put them on a number line, and then we're going to have to test values in between to see if each interval is positive or negative, and then answer the final inequality in interval notation. All right, so let's use this guidelines now on some examples. So first one here, step 1, we want to get it equal to 0. This one you can see is already compared to 0, so we can check that one off. Next step is to do some factoring. So what we want to look at here is what's going to multiply to 6 and also add to -5. Looks like we can do that with x minus 2 and x minus 3. Okay, so now we got that step checked off. Next step, we want to figure out the values here that will make this equal 0. Now I know we don't have an equal sign here, but we want those values where it equals 0 so we can test the ones in between. So what numbers are going to make these equal 0? You can probably kind of look and see. It looks like here 2 minus 2 would equal 0. Here 3 minus 3 would also equal 0. So the two numbers we're going to be using here are both 2 and 3 on our number line. If it was a little bit harder and you couldn't just look at it in order to figure those out, you can just take the number, or take the factor, set it equal to 0 and solve it, and that would give you the same thing. So if it's a harder one, set it equal to 0 and solve. Okay, so that's step 3. Step 4 here, now we want to test the intervals. So between 2 and 3 and outside of 2 and 3, what's going on here? So let's start in this interval right here, bigger than 3. If we pick a number bigger than 3, like 4, what happens if we put 4 into our factored inequality? Well, if we put 4 here in for x, 4 minus 2 is going to be 2. 4 minus 3 is going to be 1. If we multiply those, 2 times 1 is positive 2. So anything we pick that's bigger than 3 should give us an answer that comes out positive. And you can try it out with other numbers and test it, but you'll see it is always true. Now let's pick a number in between 2 and 3. Now this is a little harder because we can't use a whole number. Let's use 2.5, 2.5. So if we put 2.5 in for the first one, that's going to be 0.5. And it really doesn't matter what it comes out to be, but we know it's going to come out positive. If we put 2.5 in for the next one, 2.5 minus 3, that's negative 0.5. And again, the result, the number part doesn't matter, but we know it comes out negative. Well, what's going to happen anytime we multiply a positive and a negative? Our answer is going to come out negative. So now we know anything we pick in between 2 and 3 is going to give us a negative result. Last, let's pick something less than 2. 0 would be easy. 0 minus 2 is going to result in a negative number. 0 minus 3 is going to result in a negative number. What happens when we multiply two negatives? We get a positive. Okay, so now we know where this comes out to be positive and negative. Now the last part, you want to test and see, or look at your inequality and see which one are we looking for. If we're looking for where this is less than 0, we're looking to see where is this negative. So the part that we want to describe with our interval then is where on our graph this was negative, that was all these values. 2 and 3 itself, we wouldn't want to count because there's no equal to on this inequality. So we don't want to actually count those two endpoints because that's where it's equal 0, not less than 0. So now the last step here that we got to do, write our inequality out in the interval notation. So in interval notation, we would write that as 2 to 3 with parentheses on both because we don't want to count those endpoints. And we're done. Let's try another one. Okay. First step, get it equal to 0. Now the last one was nice because it was right equal to 0. This one is not. So now we got to move some stuff around. So let's get this x squared out of here. Let's subtract it to the other side to start with. So now this cancels out. This is going to be compared to 0 like we want. On the other side, 2x squared minus 1x squared is going to be 1x squared. And then we still have that minus 3x. So that was step 1. Step 2, factor. This is a different type of factoring here. We have a greatest common factor of x we can cancel out. So if we factor out that x, there would be one x left there, and the other one we'd have a 3 left, so x minus 3. So step 2 is done. Step 3, come up with our values where it equals 0. On this one, 3 would be a number. 3 minus 3 is 0. And then the other one would be 0 over here, because if you put 0 in that, 0 times anything is going to be 0, so that would make it. So our two numbers here are 0 and 3. All right, so that's step 7. Next step, now we're testing those intervals. Let's pick something bigger like 4. If we picked 4, that's going to be positive 4. 4 minus 3, that's positive 1. Two positives are going to multiply to a positive. If we pick something in between, let's use 1. If we use 1 putting in is positive. 1 minus 3, though, that's going to come out negative. If we multiply a positive and a negative, that region's going to come out to be negative in values. Our last interval has to be something less than 0. Let's use negative 1. Well, that's going to be a negative number. Negative 1 minus 3, that's a negative number. If you multiply two negatives, you're going to get a positive. So now we know what type of numbers we're going to get in each interval here. We can now look at our inequality to decide which one are we using. We're bigger than 0 on this one. We want positive. We want the positive regions. So on this one, we want to have this region because that's where positive, this region because that's where positive, and these would extend out here. What about the numbers themselves, 0 and 3? Here we do want to include them because we see the equals to sign on here. So the last part, right out now, the inequality or the interval notation for these two regions. Since there's two regions, we're going to have to use one of those unions. The first one would be all the numbers from negative infinity to 0. We do want to count 0 because it's equal to, and we got a filled-in dot there. The other interval starts at 3, and we want to include 3, so bracket again. And that one extends out to infinity. So there would be our interval notation for the points that make this work. Okay, next one here. Again, we see it's not equal to 0. So first thing we got to do is get that equal to 0. Let's subtract a 1 over. There's no like term to that, so it'll end up being 2x squared plus x minus 1 greater than or equal to 0. Now, next step, factor. This one has a 2 here, so we know there's going to be a 2x and a 1x. What's going to make this one work? Well, we know the number's got to multiply to negative 1. So I think if we go negative 1 plus 1, it works. Should just double check quick. Those two would multiply to 2x, negative 1x. Do those add up to 1x? Yes. So that's the correct factoring there. Now we want to come up with that number line. One number here that we know should work with this one is negative 1. So negative 1 is going to be on there. The other one's a little bit harder to see because now we got that 2 in front of there. So remember how we said you can do that. If you're not sure, take what you got there, 2x minus 1, set it equal to 0 and solve it. And you can find that value out. Here we're going to have to divide by 2. So the other value is positive 1/2. Those are the two spots where it equals 0. Now our next step is to test. Let's test a number bigger than 1/2, like 1. If we put 1 in there, 2 times 1 is 2, minus 1 would be positive 1. So that's positive. 1 plus 1 is positive. 2 positives is going to make that positive there. Something in between, 0 would work good on this one. So let's use 0 to test the next one. If we pick 0, now the first thing here, 0 times anything 0, 0 minus 1, that's going to come out negative. 0 plus 1, that's positive 1. A negative times a positive is going to give us negative there. Last region we got to check. What happens if we put like -3 or -2 or some number smaller than -1 in there? First thing's going to come out negative. This other one's going to now come out -2. Two negatives multiplied to a positive. Now we're writing out our interval. We want to know, where is this bigger than 0? That's positive. And so our positive regions came out to be here and here, extending out. We do, again, want to count our endpoints because it could be equal to 0. And now write out the boundary or interval notation. -infinity, and we always use parentheses with any of the infinities, to -1. We want to count it. Union 1/2 out to infinity. That's where it would be bigger than or equal to 0. All right, I want you to pause the video, try this last one out, see if you can solve that. All right, let's see how you did here. First thing, we got to make sure this is equal to 0, so you're going to have to move these numbers over to the other side. You should end up with this now less than 0. If you factor that, you should have gotten these two factors. Our two numbers are going to be +4 and -1 here, so put those on a number line. Test them out. You should have found that we get a positive, a negative, and a positive region. This one's less than 0, so that would be our interval right here in between the numbers. We don't want to count the endpoints because there's no equals to, so you should have had open circles, which results in that solution. All right, so just reviewing again, what are the 5 steps? Compare it to 0, factor, find the number line, test the intervals, write your solution. All right, the other examples we're going to look at are these nonlinear ones. Express this in interval notation again and graph on a number line. So the first step doesn't change. We still want to get this compared to 0. So here it looks like we need to subtract 1 to the other side. So now our inequality looks like this. On that left side, in order to figure out what we're going to want to use for our number line, we need to get that to 1 fraction. Right now, we got two things being subtracted there. So what we got to do is come up with a common denominator if we want to subtract something that's with a fraction. So this 1, we got to multiply on the bottom by 1 minus x. That also means on the top, we got to multiply by 1 minus x, not x minus 1. Okay, so if we do that, now it looks like this. We got 1 plus x over 1 minus x, and we got minus 1 minus x over 1 minus x. Let's now push that together. Since we got the same denominators, let's combine that into 1 fraction. So if we make that into 1 fraction, now it's just 1 fraction of 1 minus x. Then we need to join and subtract the stuff on top. So we got 1 plus x minus this inequality of 1 minus x here. And notice I put that in parentheses. Because we are subtracting here, we're going to have to distribute that negative sign to both. So now what we got on top is 1 plus x minus 1 plus x. Okay, so last thing, let's combine like terms. Our 1 and -1 should cancel out there. X's don't cancel out. We need to add those. X plus x is 2x over 1 minus x. Okay, so that is now our inequality. Now we have to pick out what's going to make that 0. Let's start with the top. What's going to make the top 0? If we set 2x equal to 0 and divide by 2, we see that 0 is one number we want on this number line. So we want 0 here. But this one has a denominator, and numbers that make the bottom 0 aren't going to make the whole thing 0, but we know that there's no value there and something's going on in the graph, notably an asymptote. So we also need to put the bottom equal to 0 and see what we get there. So if we put the bottom equal to 0, solve this one, we could like add an x here to the other side, and now we get that x equals 1. So that's another number we need to check on this number line, because even though it doesn't make it equal 0, there's an asymptote there and things can be going on. And just to remember that there is no value there, I'm just going to put a little asymptote line to remind us that there's an asymptote at 1. All right, so now we want to do like we did before, test values bigger, middle, and smaller than the ones we got there and see what we get. Let's test 2. That's bigger than 1. So if we put 2 in for x, the top's going to come out to be positive. 2 times 2 is 4. On the bottom, 1 minus 2, that's going to come out to be negative 1. That's a negative. What happens if we divide a positive and a negative? We're going to get a negative result. Let's pick something in between, like 0.5. If we put 0.5 in, 2 times a half, or half of 2 is 1. That's positive. If we put half on the bottom, 1 minus a half is a half. That's positive. If you divide two positives, you should get a positive. Let's test the numbers less than 0, like negative 1. If you put negative 1 in, the top's going to become negative. 1 minus negative 1, if we got minus a negative, that's like plus, so that's actually going to come out to be positive on the bottom. If we take a negative divided by a positive, our answer is going to come out to be negative. So now we know the regions where this is going to come out positive and negative. The last step is to, again, write your interval out. So on this one, since we're looking greater than 0, we want the positive regions. The positive region on our graph would be right in here. We're not counting the end points because we don't have the equals to. And even on the asymptote, had there been one, we won't want to count that because there's no value there. So the numbers that are going to work in this one are any number between 0 and 1 should make this inequality true. So on this one, even if you want to go back, you should be able to test it. If we pick something between 0 and 1, it should make it work. If we pick anything else, it's not going to come out true. Let's test something not first, just so you can see it. What if we put something not between 0 and 1, like 3? What would we get if we put 3 in here? Well, on top we get 4. On bottom we get 1 minus 3 is negative 2. That result ends up equaling negative 2. And then we have it bigger than 1. Is negative 2 bigger than 1? No, that's false. That's not true. It's not going to come out to be true unless we pick something between 0 and 1. What if we put a half in there? If we put a half, that should work. 1 plus a half is 1.5. On the bottom, 1 minus a half is 0.5. If you do 1.5 divided by 0.5 on your calculator, you're going to get 3. Is 3 bigger than 1? Yeah. So you can see that it does hold up and is true what we came up with. All right, next one, another nonlinear one. So first step again, get it compared to 0. Let's subtract all this stuff over to the other side here. So now we'd have x minus 2 over x minus 1 less than 0. We want to combine this into one fraction now. So like we did before, on the bottom here, we want the same denominator. That means the top, we're going to have to multiply by the same thing. So now as one fraction, we're going to have, and it looks like we got to do some distributing here. We got x times x would be x squared minus an x. And then we got minus 2 from the other part here, this minus 2 here. And that should all be less than 0. To check that, the bottom simplified. Let's see if we can factor the top like we did on some prior problems. So what's going to multiply to negative 2 and add to negative 1? Looks like x minus 2 and x plus 1 do that. So now, on our number line, which numbers do we need to check? Well, let's start with the top. Where does it equal 0? It equals 0 at 2. It'll also equal 0 at negative 1. But we also have a value that's not going to work in this problem, and that number is 1. 1 minus 1 is 0, and you can't divide by 0. So at positive 1, again, we're going to have an asymptote. So I'm going to put an asymptote there to help us remember we don't have a value there. All right, so now let's test out and see what we get. If we pick something bigger than 2, like 3, this term's going to come out positive. This term's going to come out positive. The bottom's going to come out positive. All positives is going to make our answer definitely positive there. If we pick something in between 1 and 2, like 1.5, now it changes a little bit. 1.5 minus 2 is going to be negative. 1.5 plus 1 is positive. 1.5 minus 1 is positive. If we multiply a negative and a positive on top, it's a negative number divided by a positive number. That's going to make that negative in that region. Between -1 and 1, 0 is a great one to test. 0 minus 2 is going to be negative. 0 plus 1 is going to be positive. But on the bottom now, 0 plus 1, or sorry, 0 minus 1, that's now going to make the bottom negative. If we multiply a negative and a positive, it's going to give us a negative. Got a negative on bottom. Dividing two negatives is going to result in a positive answer. We got one last region. This one's got an extra region because we had another number we had to check. What if we pick something less than -1, like -2? Well, now every term here should end up coming out negative, which means on top, we're going to get a positive number. Bottom is a negative number. Dividing those would make that negative. All right, so now it's just writing out our answer. Here we want to know where is our numbers less than 0. We're looking for negative on this one. So on our graph, that would be all the numbers here and all the numbers here. We're not equal to, so we don't want to count any of these values. So our answer would be -infinity to -1. We don't want to include -1 because we're not equal to 0. Union all the numbers from 1 to 2. So that would be our solution there. Okay, last one. Let's have you try this one. So pause and see what you come up with. All right, let's see how you did. First thing, you got to make sure you get this equal to 0, so subtract 3 over. Now we're going to have to get a common denominator here, so multiply by x minus 5 over x minus 5. On the bottom now, we're going to have that common denominator. On top, we got to make sure we distribute here, resulting in that. Combine the like terms. You should end up with this now compared to 0. The two values that are going to make this 0 are 5. And then also on top, be careful there, it would be 16 would make that, because if you put this equal to 0 and add an x over to the other side, you can see positive 16 is the other one, not negative 16. So now if you test those, you should have came out with the negative, positive, negative shown there. We're looking for where's this negative, where's this less than 0. So that would be the regions here and here. So it's all the numbers less than. Now, even though we have a equals to there, we don't want to put a filled in dot there, because you can see I put this asymptote line. There's no value at 5. It's in the denominator. So that's got to be open circle, because we can't have a value there. But 16 we can close in. That one, 16's on top. That would make it equal to 0 going that way. So your final answer on this one would be -infinity to 5, not including 5 because it's not in the domain. There's an asymptote. And then 16 we do want to count off to infinity. So if you had that, very nice job. You did great on that.